Hello and welcome back to Harry's Jeti Clinic. In this episode we're going to look at having two completely independent receivers such as you might have in a large model. You might have one on the left hand side and one on the right hand side. And this is going to be a slightly different variation of the double path method. We've looked at in other videos at using the double path method where one receiver is the primary receiver and handles all the servos, and the other receiver is simply a secondary. It's acting as a satellite, and it has a data cable passing the signal to the primary receiver. It has no servos connected to the secondary receiver. And if you're ever thinking of connecting servos to the secondary receiver in that method, please don't, because the ports on the receiver that you plug the data cable into are not necessarily designed to handle the sort of currents that a servo would pull. So what I've got here is two receivers, and they're bound to the transmitter in the standard double path method. So we've got a Rex 10, which we'll use as the left-hand side of the aircraft, connected to that servo there, and we've got an older R8 with that servo there. Notice that both of them have an independent power supply. You could, Y lead it, come from the same regulator, whatever. I've just happened to have two batteries around, so I've powered them quite independently. And importantly, there is no data cable between the two of them. I suppose you could always put a data cable there that would allow the R8 to send its signal to the R10, the primary, just in case the primary lost its signal, but it wouldn't provide any backup in the other direction for this receiver. And also I'd be very concerned about any attempt by that cable to try and common the power supply between the two and start passing currents that shouldn't be there on those pins. So completely independent. Now, at the moment, the servo is plugged into socket 2. And if we go into servo assignment, we can see that channel 2 is aileron 1. It's the left-hand aileron. The right-hand aileron is on channel 12. That's aileron 2. But your receivers by default map channel 1 to socket 1, channel 2 to socket 2, etc. And just to prove that for the moment, I've put a huge amount of aileron differential in, and to show you that these two servos, the one on the left of the model and the one on the right of the model, are actually getting aileron 1, which is for the left of the model, I'll operate the aileron stick. If differential was working properly, one would move a long way and the other a short way. But they're both moving a long way, and they're both then moving a short way when I push the stick the other way. That's because both of them are getting aileron 1, the left aileron. How do I get aileron 2, which is on channel 12, out of a socket here? Very simply. We go into Device Explorer, into the relevant receiver, down to its receiver outputs. And this shows the mapping of what Jeti calls out pin. That's the socket number. So that's socket number 1. And what it's getting is channel number 1, which is throttle 1. And at the moment, of course, socket 2 is getting channel 2, which is aileron 1. I simply have to come down to there, change it. If I scroll down the list, it shows all the possible channels. There it is, aileron 2, channel 12. Say OK. And now socket 2 is getting channel 12. Imagine that you have a 16-channel model and you want completely split left and rights. You put an 8-channel receiver on the left-hand side. You put a 9-channel receiver on the right-hand side. You can come to the right-hand side receiver and simply change it out pin 1 to be channel 9, out pin 2 to be channel 10, out pin 3, channel 11, and so on. And they don't have to be in sequence. That could be channel 16, channel 4, channel 9, channel 10, channel 7. You map it how you want it. It's obviously just easier in your mind to keep track of things, especially when you come back weeks or months later to check on something, if you followed a nice consistent pattern, but you don't have to. Let's just prove now, say OK to it, that that has worked and that this genuinely is getting aileron 2. That's why I put in all that massive amount of differential. Remember before, when I moved the stick, both servos either moved a long way together or they moved a short way together, when they should have, one moved a long way and two moved a short way, or moved a short way and moved a long way. I'll push the aileron stick, and there you go. One's moving a long way, one's moving a short way, and now the one on the right should move a long way, and on the left a short way. So there you are. We've remapped. And you can do this with central boxes as well, if you have to. However, another difference to the double path method is that if you were using this as a primary and this as a secondary with an interconnecting data cable, you would disable the failsafe in the secondary. But we're not connecting them anymore, and we need the secondary to go into failsafe should it lose its signal. So therefore, here's an important difference. In the double path system, this is what would be considered the secondary. Come on, little camera, refocus. There we are. That's the secondary, and you would go into failsafe and you would disable it. But because we are using them completely independently, it's important that the right-hand receiver can go into failsafe. It may have, for instance, an engine throttle on it on a twin or whatever. So enable it, come down here and set your failsafes. Okay, hope that's of some use to you.